Let's start with the net present value approach. The idea is we are going to accept that investment project that generates profit. So how do we find profit? By definition, profit equals revenues minus costs, right? So in a typical investment project, what happens is you invest money today, which is year zero. There is no revenue that you receive right away, you invest. So maybe let's take a step back and think about some examples. In the corporate world, what would be an example of an investment project? For example, one company would like to acquire its competitor, right? So a lot of money should be spent to buy that competitor, right? But the point of that is to, kind of generate an even larger profit every year in the future, right? Or maybe an example with some restaurant chain. And this restaurant chain is considering opening a new location in some specific geographic location. Is it worth it or not? Again, there would be large upfront costs. Maybe like some building needs to be built or purchased, buying furniture, paying some interior designers, right? All of that will cost a lot of money. So there's a large upfront cost involved in any investment project. But in return, there would be money coming in the future years. So in a typical investment project, in years 1, 2, and so on, there will be revenues coming in. And of course, there will still be some miscellaneous expenses, such as paying taxes on your corporate income, paying wages to your employees, paying utility bills, all sorts of maintenance, right? All of that will still be taking place, but not on the same scale as the upfront cost in the beginning. So in a typical project, let's say it's a 4-year project, there will be a large cash outflow today. A lot of money would be spent, and we call it an investment cost or initial investment. And in the next 4 years, in this 4-year project, there would be cash inflows, right? Money received or annual profits. So to use the net present value technique, we are going to see whether overall we are going to see money coming in. If that's true, the project should be accepted. So the net present value rule says if overall money coming in from a project is greater than $0, then the project should be accepted. Let's see how the net present value technique works in this problem. You're thinking about opening a coffee shop. It will cost you $650,000 today to buy coffee machines and all other equipment. So $650,000 is a large cash outflow in year 0, right? Which is today. You estimate that your coffee sales will generate $90,000, $120,000, $170,000, and another $170,000 in the next 4 years. So one number at the end of each respective year, right? You will then sell all used equipment for an estimated $250,000 and start a different project. The proper discount rate is 8%. So this is what was given to us. We are working with a lot of numbers. It might be really helpful to start solving this problem by drawing a timeline. Under year 0 or today, you're going to put negative $650,000. At the end of the first year, you put $90,000 in profit from sales, right, which was given. At the end of the second year, you put $120,000. At the end of the third year, you put $170,000. At the end of the fourth year, you put $170,000 again, plus another $250,000, which is how much we get when we sell all used equipment. So why don't we simplify what's going on at the end of the fourth year and replace it with the sum, 420,000. So 170K in profit from coffee sales plus 250,000 from selling all used equipment is simply $420,000 that would be coming in that year. And the question is the project worth it? Should we accept it? Should we start this coffee shop business or not? Or should we walk away from this investment opportunity? Here's how we should solve this problem. First, how much money will the project generate in the future years? Well, we already know what the future numbers look like. In year one, it's $90,000 that would be coming in. In year two, $120,000. In year three, $170,000. And in year four, $420,000. The next question is, let's calculate how much in today's dollars this project will generate. So essentially we are asked to sum up the 4 future cash inflows, right? Except the phrase in today's dollars implies that we need to take into account the whole time value of money. In other words, we need one by one to discount each of these 4 future profits and then add up their individual present values. So for example, the first year profit of $90,000 is worth a little bit less than that today. It's discounted, and we discount it by dividing 90,000 by 1 plus the 8% discount rate which is given. So we can just divide by 1.08 for simplicity. The second year's profit, $120,000, is divided by the squared 1.08, right? Because it's 2 years in the future. And so on. The third year's number is discounted back by 3 years, so the power attached to 1.08 is 3. And the fourth year profit of 420,000 is divided by 1.08 to the fourth power. Then the third step is, what's the overall profit of this entire project? Again, in today's dollars. So why are we doing everything in today's dollars? Why are we discounting? Because today is when we need to make this investment decision, right? So we need to, we cannot compare apples with oranges. We need to compare apples with apples. So today we would be investing $650,000, right? This was given. And in today's dollars, the project will bring us $629,878, right? From the previous calculation step. So the total present value of future 4 profits is $629,878. That's how much money we would get. But it will cost us $650,000 today to start this whole thing. So when you calculate the difference, right, money coming in minus money coming out, you get negative $20,122. So the overall profit is negative, which means we are going to be losing money. Now, it looks like it's a pretty complicated calculation, right? Actually, you can do the whole thing in one step. Cash flow keys. So before I show you this cash flow key solution, how would you, make a recommendation regarding this project? Because you would be losing money, you would not recommend launching this project. So you say that the project is not worth it, or you can say the project should be rejected. Now back to the cash flow keys solution. In the past, we would use the cash flow keys to find combined present value of multiple future cash flows, right? And so normally we would use $0 for cash flow 0. Not this time. This time, for cash flow 0, we are going to put the initial investment amount, $650,000, and we're going to make it negative. So let me bring up my financial calculator. Let's turn it on. As always, let's start by clearing it, a full reset. Second, plus minus, enter. Let's start. I press the cash flow button. Cash flow 0 is currently set at 0 by default. We want to change it to a negative number reflecting the cash outflow in the beginning of the project, which is 650,000 negative. So I put 650,000. To make it negative, I press the plus minus key on the bottom, and then I save it by pressing enter. Down arrow key. Cash flow 01. That's the first one in the future. What is it? It's $90,000, right? I put 90,000. Because it's money coming in, I leave this sign as is. In other words, it's positive. I press enter to save this number, and I press the down arrow key. F01, frequency of my first cash flow that I have just entered. It's only once in a row, and so I leave the frequency at 1, which is the default. I can then save it by pressing enter and then press the down arrow key, or I can just press the down arrow key without pressing the enter button. CO2, cash flow number 2 in the future. That's $120,000. So just like the first cash flow, I press 120,000, enter, down, and down. Next one, cash flow number 3 in the future. It's 170,000. 170,000, enter, down, down. And the last one is entered similarly. 420,000, enter, down, down. And we are done with the cash flows. There is no more cash flow number 5. Now I should tell the calculator that I want to find the net present value. So my goal is to get negative $20,122. And I'm gonna do it within the next few seconds. I press the NPV button. What's my I? I is the discount rate. It's given, 8%. I press 8, enter, then down, and compute. This is my answer. Negative $20,121.99. So it's approximately negative $20,122, like I show on my slide. Okay, so in one step, you can find the net present value. One step in the financial calculator, the so-called cash flow keys. And the new thing that we were doing just now, we were entering cash flow 0 as a negative number, and everything in the future is positive. So to summarize, we were calculating the overall profit from a new investment project, and it's nothing but the project's net present value. How is net present value defined? Net present value, or NPV, is the present value of all expected future cash flows less the initial investment, because the initial investment is today, right? We don't find its present value. It's already at present. We simply subtract that large expense. The textbook defines the NPV slightly differently. It says that the NPV equals the difference between investment's market value and its cost. So what's investment's market value in our example that we just did? It's the present value of all expected future cash flows, which was $629,828. And the project's, the investment project's cost in our particular example was the initial investment of $650,000, which was given. So when you find the difference between the two, you get the NPV. And the NPV rule for making investment decisions is you should accept an investment if the net present value is greater than $0. Otherwise, if the NPV is less than $0, the investment project should be rejected. It's not worth it. So what does a positive NPV mean? It means that we are going to receive more money in the future than the amount that we would need to invest upfront. And a negative NPV means the opposite, that we would be spending more money upfront than how much would be coming in the future. What about the NPV equal to exactly 0? In this case, we say that we are indifferent between investing or not investing, accepting the project or rejecting the project. So you can argue and say that you should probably just reject it because it's not worth the time, right? But in finance, for the purpose of this class, I guess, we are not considering like the effort you would be putting in, the time you would be spending on this project, and how much, how you would monetize that. So we're not looking at those kind of non-monetary things, how they affect the way a project should be looked at. So we are saying that we are indifferent if the NPV is 0. In my opinion, for a big project that costs, let's say, millions of dollars or billions of dollars, what if you get the NPV of, say, $1,000? I would probably say that the project should be rejected because you only get $1,000 out of millions and millions that were invested. So again, it's one of those cases in which you can say that, well, it's kind of not worth the time and all the effort, right? But that's kind of in practice, in real life. In theory, which is what we are learning in this chapter, as long as the NPV is above $0, even if it's 1 cent, we say that the project should be accepted.